All right, by now you should have completed your first progress check in Canvas. And today we're going to talk about identifying the different types of functions. So, function notation. This was a big question last year, so we're going to go over it in a little bit more depth. So, to be a function, as we talked about yesterday, we know that the x values or the domain of an equation cannot repeat. Therefore, functions are specific types of equations or relations, and not all of them have the title of being a function. So, as a result, we need a special way to denote them. And to do this, we're going to use what's called function notation. So, the regular way we would write a linear equation is y equals mx plus b, where m is the slope and b is the y-intercept, and they're real numbers. Well, since a straight line, which represents a linear equation, is a function, meaning that the x values or the domain does not repeat, we can write it using function notation. Function notation for a linear function is f parentheses x is equal to mx plus b, where m and b are still real numbers. And that f parentheses x can be read as f of x is equal to m times x plus b. So f of x, this thing right here, is your function notation. Basically, it's saying that whatever is on this side is a function, meaning that the x values will not repeat. We will use this a lot in our next topic, and we'll talk about evaluating functions. But this is basically representing y. We're just telling you that when I plug a certain number in for x, that value is equal to f of x. So f of x is basically y, but it's function notation. So when you see f of x, it's telling you that this is a function. So more about function notation. So what changed from the way we denote linear equations to how we denote linear functions? So we'll compare them side by side. Linear equations, y equals mx plus b. Linear functions, f of x is equal to mx plus b. So I'm not actually changing the equation. I'm really just replacing y with f of x. Y is the output, meaning whatever you put in for x will generate y. And f of x is the output, meaning whatever input you put in for x, hence f of that value will generate some output for equal to f of x. All you're doing is swapping f of x and y. Parent functions, okay? There are 4 functions that we're going to talk about today: linear, exponential, quadratic, and linear absolute value. But we're mainly going to focus on the first 3 throughout the year. All functions originate from what's called a parent function, and each of the 4 that I just mentioned have their own parent function. The parent function dictates basically how the graph started, and all of the other types of graphs are just transformations of the original version. So if we think about it like a family tree, your parent is the original member of your family. Then you, the child, you're similar to the parent, but you're different. You have some different genetic makeup. And then the grandchild still has things that relate back to your parent, their grandparent, but is even more of a variation from the grandparent. So here, when we think about a parent function, it's the original graph. Then after I've done one transformation, it would be kind of like the child. It's still pretty close to what the parent function looks like, but there's a little slight difference to it. And then if I do multiple transformations on a function, it's going to look like the grandchild. So it still has attributes of the parent function, but it looks kind of different from the original. Okay, so one of the 4 types of functions we're going to discuss is linear functions. The function form is f of x is equal to mx plus b, where m and b are real numbers. M is the slope and b is the y-intercept. You should have talked about that a little bit in 7th grade. The parent function of f of x is equal to x. So that's the parent linear function, and it looks like this. It's just a straight line with a slope of 1, up 1 over 1, that goes through the origin. This is the original linear function. It's the parent function. Now later on, we'll talk about moving this function around, but this is the original. Linear functions, what does their graphical behavior look like? Well, it's going to be increasing or decreasing over the entire domain, meaning it's always going to be increasing or it's always going to be decreasing. There's no switching halfway through in the middle. There's no such thing as a maximum or minimum value, right? Because the line's always going to go forever up or forever down. It's made of straight, I don't know why it says straight bags. It should say it's straight lines, hence the name linear. Domain is going to be continuous, so it's going to go on forever in the x. And if it's a continuous graph, it's all real numbers, meaning it goes forever to the right, forever to the left. If it's discrete, it's all integers. Remember, discrete is our dot graphs, so it would just be dots throughout that. The range, if the graph is continuous, it's going to be all real numbers because it's going to go forever up, and it's going to go forever down. Discrete are going to be all integers or a single value, and we'll talk about that a little bit later. So exponential functions are the second main type of functions that we're going to talk about. The function form is f of x is equal to a times b to the x plus c, where a, b, and c are real numbers, and b is greater than 0 but less than 1. The parent function is f of x is equal to 2 to the power of x. And here is our parent function, okay? Our parent function, it has a y-intercept at 0, 1. And it does not actually touch 0, even though it looks like it does. It just gets closer and closer to 0. When we dive deeper into exponential functions, we will call that the asymptote, meaning it's going to get closer and closer to that line, but it won't actually touch it. And then it's either going to curve straight up, or we have exponential functions that curve straight down. So it's the same thing as linear. It's increasing or decreasing over the entire domain. There is no maximum or minimum because it's either going to go forever up or it's going to go forever. It's eventually going to come straight down, or it's going to go straight up. It's made of smooth curves. On a continuous graph, the domain will be all real numbers because it will go forever left and forever right. Discrete will be all integers. The range for a continuous graph are all real numbers greater than a value or all real numbers less than a value. What do I mean by this? Well, I said this is going to get closer and closer to 0, but it's never going to touch 0. So the range for this is actually y is greater than 0 because it's never going to touch 0, but it'll be everything above 0. Discrete graphs are all integers greater than a value or integers less than a value. It's the same thing. If this was a dotted graph instead of continuous, it would be y is greater than 0, but then we'd put a special caveat that it's all integers greater than 0. Quadratic functions, the function form is f of x is equal to ax squared plus bx plus c, where a, b, and c are real numbers, and a cannot equal 0. The parent function is f of x is equal to x squared, and this is what the parent function looks like. This graph is called a parabola. It can either be this U shape or it can make like an N shape if it's flipped upside down. But this is the original, that parent function. Now you can see compared to the first two types of graphs we have, there is going to be some kind of switch halfway along the way. So it's going to increase then decrease over the domain, or decrease then increase. So if I look at this graph, I'm decreasing, 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 and then at some point I'm going to turn into increasing. If it was the other way and shaped like an N, I'd be increasing, 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 and then at some point start decreasing. So it's going to do both, depending on whether it has a maximum or min. It can have either, depending on the shape of the parabola. So here, this is a minimum value because you can see everything is above this lowest point. If I had a maximum value, everything would be below that highest point. It's made of smooth curves. The domain for continuous is all real integers, or all real numbers. Continuous will be all real numbers. Discrete would be all integers. The range, if it's continuous, it's all real numbers greater than or equal to the minimum, or all real numbers less than or equal to the maximum. It will touch this point, so we will include that in the range. And if it's discrete, it'll be all integers greater than the minimum, or all integers less than the maximum. Okay, linear absolute value functions, we will talk about these the least. You just have to know them and know what they look like, but you'll actually dive into how they work more in Algebra 2. So a linear absolute value function is f of x is equal to a times the absolute value of x plus b plus c, where a, b, and c are real numbers, and a is not equal to 0. The parent function, or the original function, is f of x is equal to the absolute value of x. And that graph looks like a sharp V, and it has an x and y intercept of 0, 0. That is the parent function. That's the original. So it can increase then decrease, or decrease then increase over the domain, just like with quadratics, because it's going to either be, it's got this lovely V shape where I can flip it upside down with a specific transformation, and it could be a sharp mountain shape. It can either have a maximum or a minimum. Again, in this case, this is a minimum, but if I flipped it around, I could have a maximum. It's made up of straight lines. The domain is all real numbers if it's continuous, and discrete if it's all integers. The range, if it's continuous, is going to be the exact same as the quadratic functions. It's all real numbers greater than or equal to the minimum, or all real numbers less than or equal to the minimum. And the range, if it's discrete, it's all integers greater than or equal to the minimum, or all integers less than or equal to the maximum. Okay, what you are going to do for some independent praxis, you are going to, on the function activity, you are going to label the function family, state whether it's linear, exponential, quadratic, or absolute value. Tell me if it's discrete or continuous, if it's a function or not a function, and the x and y intercepts. So here I have a quadratic graph. I can tell by the shape of the parabola. It's an N shape. It is continuous. There's not a bunch of dots. It's a line. It is a function. Remember, back to our vertical line test, I want to make sure it doesn't hit more than once at one time. The x-intercepts are 0, 0, and 2, 0. Remember, that's where it crosses the x-axis. And the y-intercept is 0, 0 as well. Here I have a linear absolute value function. It is continuous as well. It is a function. The x-intercept is 0, 0, and the y-intercept is 0, 0. That is what you are doing, and it is on the function activity, and it's in your packet. You do not have homework for tonight unless you do not finish that function activity. That is your homework if you do not finish it.